and it'll be hit every time after it's been hit at least 11 times.
Got it. What other conditions are there?
The,
what types
the
of
last type of condition that we have is called a filter breakpoint, and I think for the purposes of this, we can gloss over that.
Yeah.
It's generally for multi-threaded or multi-process code. You basically ask the debugger to break based on the machine, process information, or thread information.
So you can not only just set a breakpoint, but you can set a breakpoint with conditions based on the first one is conditional expression, a filter, or a hit count.
That's correct.
Perfect. Cool.
And then the last type of thing that we can do as well is we have this actions checkbox down here. You can ask the debugger to print a message when you hit your breakpoint rather than and actually automatically continue execution.
Mm-hmm.
So if this is a lot of times very useful inside loops as well, if you just want a record of everything that happened, then it goes to the output window. So I can type plain text, so I'm going to say hello, and then anything inside a curly brace. So I type this is going to be dump the actual value of it at runtime. So let's pick shape name here. And then we have other information via $sign called pseudo variables. So I could, for example, give the name of the function that I'm currently in, or dump the call stack or something
cool.
like that. So let's go ahead and do that just to show that working. We showed the conditions working. I can disable the condition without having to delete it. So
Cool.
if I spend some time setting it up.
This looks like a new window. Is this a 2015 thing?
This is new in 2015.
Okay.
In 2013, in previous versions, all this functionality was available in separate dialogues.
Yeah.
We took them and combined them into one, and you accessed that. We didn't have this nice little bar up here. You had to right-click, and then they had various context menus.
Right.
So we've collapsed them down to conditions and actions now. Condition was always condition. When hit was this trace point functionality on here that we're about to look at, the logging the message. You had hit count was its own thing, and then filter was its own thing.
Is this trace thing new?
No, this has been in there as well.
Man, because I have been sillily, is that a word? I've been silly and doing my console.write lines, but this is a way to do it, but as a debugging thing, and not necessarily in the code.
Yeah, absolutely. So let's go ahead and run this. The other nice thing about this new window is it's non-modal, so I don't even have to close it if I don't want. I can just click Start Debugging, and then let's type our shape name, rectangle. I hit this, and now if I go to the output window, so view, output down here, I can actually see the message that I printed, hello rectangle, and then the name of the function that I was in.
That's really cool. And I think the cool thing about that is you can print it out without having to stop.
Absolutely. Yeah, and that was if we go back up here, that's this checkbox that says continue execution. If I unchecked that, you'll see that the shape of the breakpoint icon up here will actually change back to a circle. And so circle indicates that we're going to stop, and a triangle indicates that we're just going to continue execution after we do whatever you've asked us to do.
Cool.
So let's go ahead and close that. And let's go ahead and stop debugging. So I think the next thing, so we've talked about breakpoints a lot, but another really useful piece of functionality in the debugger, which is kind of conceptually a one-time breakpoint, is stepping.
Right.
So let's start debugging. Let's enter the name of our shape here. We're going to enter that. And so I could, if I wanted, I haven't actually implemented the functionality yet, but I'm going to say, okay, I'm going to try to figure out what's going on. I want to see the flow through this if statement. I could set breakpoints down here and make sure that all of those get hit, but a better option is to just step in the debugger.
Right.
And the debugger has several options for stepping. So I realize I should actually add a little bit of code here. So let's actually calculate the rectangle area now. Let's make a function call to do that. So now when I start debugging, we're going to say, so what I'm expecting is I'm expecting it to prompt me and ask me for the values of the rectangle.
Right.
So I'm going to say rectangle, and boom. And so I can step in the debugger. Normally people use the keyboard. It's kind of the easier way to do it, but we'll show up here. We have icons, and you can also do it from the debug menu. So F10 is going to do a step over,
Okay.
and that means in the context of a function call that we're going to not go into that function. We're just going to step over it and execute it, and I'll show what that means here in a second. The other option we have is step into. So for example, you go ahead and use step over to get down to down here. And so now if I go calculate rectangle area, if I choose step over, I'm not going to step into the rectangle area. I'm just going to enter height, let's say 5, enter width 4, and then now execution, right? The debugger never stopped down in that particular method.
What happens when you do a step into where it's just an expression, like shape name equals circle? Is it the same as just doing a step over?
Yeah, so that's a great question. If you step over, do a step into on something that there's really nothing interesting to step into, the debugger is going to treat it like a step over.
Got it.
But if I do it on something like my rectangle area here, which is another interesting thing you can do, you can actually change where the debugger is executing. Notice we're down here. I grabbed this little yellow arrow. I dragged it back up.
I see.
I'm going to execute calculate rectangle again.
Hold on, that happened really fast. This is something I haven't seen. So the yellow arrow is the execution pointer of where currently we are in the program.
Correct.
You said, I want to go back.
I want to go back. Yeah, let's do it one more time. So let's say height 5, 4. I'm down here. I wanted to step into that. I went ahead and just grabbed this. I dragged it up, and it means I'm going to now start execution here again.
That's cool. I did not know that.
There's a few limitations to that. Like I can't step into a different function that I'm currently executing because that would be very weird.
Yeah. Things could happen. There could be explosions.
So it has to be within the normal execution flow of your sort of application. We try to prevent you from shooting yourself in the foot, so to speak, and really screwing things up.
Okay.
But now I'm going to choose the step into functionality, and instead of calculate rectangle just executing on its own and then me stopping on the other side of it, I'm going to, when I choose step into, I'm now down here in the calculate rectangle area function itself.
And then the locals change because you see everything that's in scope there?
Yep. That's absolutely correct. And then, of course, my autos, it's actually telling me there's nothing interesting at the moment in the autos. And I'm going to start using the keyboard now because it's a little easier than clicking up there. And as I step, like we talked about, you're actually going to see the autos change as I move through the code because it's deciding what's interesting in the current function that I am. So enter my height. Let's make it a really big rectangle now. It's 10. And then it's going to prompt me for my width. And so I step over that again. Let's say a 5 now. And so I can continue to step like that.
Got it.
The last piece of really, that can be really, really useful is you could imagine that, okay, I'm done. I validated that everything's useful down in this function. I just want to get back up to where I was. Now I could scroll back up. I could find a breakpoint, and I could hit start debugging again. So if I'm down here, I can set a breakpoint. I can continue. I can run to that breakpoint. I can unset it. I could have done that to get back up here after the end of the function. But we also have another piece of functionality that is called step out, and that's shift F11. And when I choose step out, the debugger is just going to bring me back, finish executing whatever current function I'm in, and bring me back up to the top of that.
I see. Cool.
So let's go ahead. So now if I step over this again, so let's do that one more time just to show exactly how that works. So let's go ahead and step into that. I'm now going to choose the step out functionality. It's going to prompt me for the height and width again, 10, 5, and now it's going to stop after that function.
So if you accidentally stepped in and you're like, oh man, I don't want to have to go through everything, you can step out of that right away.
Yeah, or not even an accidental step in. They're trying to find a bug or validate that something works at the beginning of the method. You see what's going on.
Got it.
And then you say, oh, okay, like I don't need to finish stepping through the rest of this method. I don't want to. It's really a productivity thing as opposed to scrolling back up, finding the right place, and then setting the breakpoint.
Got it.
Although while we're on that subject, we probably should at least talk about the call stack window, which is also not there. But another useful thing that you can do for that to save you scrolling functionality, so I'm going to go ahead and step in here. I'm going to open the call stack window. So all of the debugger tool windows are available under the debug menu, the windows. Here, that's an interesting piece of functionality. No, most people we see when they first come into Visual Studio naturally go look on the View menu because that's where most of the windows are. So it's a logical place to look. Unfortunately, that's just not where the debug windows are. We put them under the debug menu. So call stack window is what I was going to show. So the call stack window shows me where I currently am. I do not have just my code on, which is what normally would have been on. So normally, sorry, nothing like changing settings on the air.
No, that's okay, because what's going to happen is someone's going to go in here and say, oh my goodness, there's all this other code. How do we turn that off?
Yeah, so by default, we have a feature called Just My Code On. And so what that does is we try to show you only the code that you actually care about. And this is normally what the default view would be if you hadn't changed your settings. Like I came in with my settings changed. And so all that stuff that says collapse down into this gray external code node right here, that was all the stuff that was taking up, making the window really tall. But if I wanted to do the breakpoint trick that I said before, I needed to go further back up. I didn't want to, I was several methods deep, and I didn't want to do like step out, step out, step out. I can navigate to any other place that this was called from by double-clicking in the call stack window. It brings me back up. I could set my breakpoint here.
It looks like it's green now. What does that mean?
Yeah, so yellow means the current location. Green means that that is on the call stack, but that's not where my current instruction pointer is.
Got it. Okay.
So as you continue to walk up the call stack, you'll see green, I guess they're not really instruction pointers, you'll see green arrows indicating that this is a
how
call site.
it got to it, yeah.
Yeah, exactly. So now if I click this continue again, it's going to behave just like we'd expect, 5, 5, just to make it easy, and now I'm going to hit my breakpoint. So call stack window is another good window to be aware of when you're going functions.
It's cool stuff.
The last thing I want to show, because I think it's a really fun piece of functionality that it's not intuitive, that a lot of people don't necessarily know. It's pretty unique to Visual Studio, is a piece of functionality we call edit and continue. So I'm going to step into this, and we actually have the ability, if you see something wrong or that you don't like, to make edits to your code on the fly.
I see.
So let's say, for example, I said, but the area is here, but let's say I also wanted to calculate the volume of a three-dimensional thing. So I can actually start adding code. So I could say, console dot write, and let's go say enter depth colon like this, and then let's go ahead and add in, that helps if I type correct things, but let's say int depth. And so now let's say, go up here and say I have to do this correctly. Oops, I guess it helps if I put it in the right place as well.
That's what we're doing, we're debugging.
We are debugging, yeah, absolutely. Let's just go down here. It'll be easier for me to not get confused if I do it down here. And then we're going to say depth equals console.read line. And this is not going to be happy because this needs to be a string. That's what that's going to return. And so depth str. And let's just be really fancy here and use a var type. And this will be an int. And now it's going to say depth equals int.parse of depth str. And instead of actually calculating the volume right now, let's just go ahead and say, let's go ahead and do it. Volume equals depth times height times width. Hopefully I remember my basic geometry. And let's do this now, console.writeLine. Volume is volume. Now if everything worked correctly, when I press F5, those code changes are going to be applied. So enter height, 5, enter width, 10, enter depth, 2. I've hit my breakpoint, but if we look up here now, we can actually see the area is 50 and the volume is 100.
That's cool. Is there limitations to the type of code you can edit during edit and continue?
There are some limitations to the type of code that you can edit during edit and continue. At the moment, we only support that for C#, Visual Basic, and C++.
Got it.
And there are certain types of edits that are not supported. We've removed most of those in Visual Studio 2015. There's a lot more limitations in Visual Studio 2013.
Oh, okay.
Meaning you can't edit Lambda expressions, you can't edit inside async code in Visual Studio 2013.
But you can now in 2015.
You can now in 2015, that's correct.
Yeah, because I remember trying to edit Lambdas, and it's like, yeah, you can't do that.
And then in 2012, because we still talk to people that are using older versions than 2013, you also couldn't do it in 64-bit code, but we fixed that in 2013.
Got it. Well, that's cool. Anything else you want to add? This is a pretty good little primer.
No, I think this is probably a great start. Maybe we can do another session covering some other stuff later.
That's cool, yeah. Well, for me, I mean, obviously a lot of the stuff was 101, but there were some gaps that were filled, I think, for me at least. I didn't know you could move the pointer around, which is kind of cool.
Yeah, that's a handy tip that, again, one of those things that you just have to know.
Yeah. Well, thanks so much for spending some time with us. Thanks for watching, and we will catch